This is the CNC Router Tips Podcast, episode 58. April was going to be the time when I switched over my production method for making triple edge finders. So I went out into the shop and I made up a big batch of triple edge finders so that I would have inventory while I made the transition. And I blew it. This is the CNC Router Tips Podcast, a show which answers one question from you, the listener, about CNC router tables, CNC software, hardware, web hosting, and business. I'll help you get started in your CNC hobby or business and help you cut through the confusion.
Today's episode is sponsored by themakersguide.com. The Maker's Guide. Useful tools for makers.
Hello, everyone, and welcome to another episode of the CNC Router Tips Podcast, a show which talks to you about your CNC router table, your adventures in making a business with it or using it as a hobby or just for fun. And we often have new people coming to the podcast, which is a really great thing, to listen for the first time, and they have no idea what it is that we talk about. So we talk about things that help you get your router table working. We talk about things that will make it easier for you when you're producing parts over and over again, and just explain some of the basics. It's been a few weeks since my last episode was posted. And I've spent most of that time reorganizing my workshop. There's been quite a bit of change in my workflow and things I do with not only the router table, but also my milling machines where I make parts for my router tables. Now, the interesting part for me has been coming up with work holding, ways to hold the parts down while they're being machined. And that's what we're going to spend just a little bit of time with at the beginning of this episode talking about. One of the things that many new people want to know about is how to hold their workpiece on the table. And really, there are a variety of ways. There's no one perfect answer, but there are several common ways that people hold their materials down. And it all depends on the type of table you have and the type of surface you have on your table as well. Many people use T-track, which is a extruded piece of aluminum or steel, which has channels milled into it, which accept bolts that will hold your part down, and you use them in conjunction with a clamp. And that's the method that I've used for the longest time on my machine. I used T-track that I got from 8020, which is a company that makes aluminum extrusions. And they have a very great presence on eBay under the 8020 garage sale. I believe that's the seller's name, where they sell their extrusion at a lower or discounted price than if you bought them at a retail store. So that's one method of doing it. And I made up some plywood clamps which slip over some 1/4-20 bolts, and I just tighten those down around the perimeter of whatever workpiece that I'm using. And that has worked very well for me in a lot of cases. But there are other times when I need other methods to hold the parts in place. And so one other method that I've used is to use what is called a cam clamp. And that is a wooden clamp that has an offset built into it so that the further you twist it, the more pressure it exerts against the edge of the wood. And I've had pretty good luck with this. The first time that I made some cam clamps, I was using plans that were made by one of our previous guests to the CNC Router Tips podcast, Peter Pasquello. And Peter made some really nice videos about that. And I'll put a link in the show notes to that video so you can see that. He also had a few other fixtures that he recommended that you use in conjunction with the cam clamps and everything in it. Really great videos. It's well worth taking the time to look at them. The advantage of the cam clamp is that it's very quick to replace one workpiece with another. You leave them in place and then you just tighten it down, or you loosen it up by just like a quarter turn of the clamp against the workpiece, and then you can take it out and remove it and put it back in place. One of the downsides of the cam clamp is sometimes it will allow the board to lift up while cutting. So you have to make sure if you're using them that you've got them down pretty tight, and then that shouldn't be a problem. Moving on, one method that a lot of people use are vacuum tables. And this is a fairly advanced method that's used on most of the commercial router tables that are out there, where you have a series of pipes beneath the table which come up to either one or more openings through the spoil board of the table, which all of those pipes are connected to a vacuum source. In most cases with the industrial machines, it's a rotary vane vacuum pump, which are quite expensive, $300 to $3,000, depending on the size you get and the power that they use. Other people use shop vacs attached to these with some success. Although they're not designed, shop vacs are not designed to be run continuously. So, they can overheat if you're not careful. There are several different ways of setting up vacuum tables. Some people will set them up with using like pegboard as the base of it, which has lots of little holes in it. And that, applies the vacuum over a wide area. There is a problem with that, though, in that the area that isn't covered by your workpiece is leaking vacuum. And so you have to have some form of cover or gasket around the outside of the material to complete the vacuum. So, that's something to bear in mind when you're choosing to use that method. Another method is to drill one or two holes into a piece of MDF and place a gasket material around the edge where you believe your part will be, and then you lay your part down on that, and the vacuum actually pulls through the MDF through those small holes and creates one high pressure area, and the gasket forms a seal and it sucks the part down, and it's very difficult to move the part when it is on one of these. It's a pretty good method if you've got a fairly strong pump. There are other vacuum tables that have grids all over them where you lay in gasket material only around the section that you use, and you can also have segments of the table which you can turn off and on so that you can direct the vacuum to only the area of the table that it's needed. And there's a lot of information about vacuum tables. One good source to look at it is the CNC Zone website, cnczone.com. There's quite a bit of talk about vacuum tables there. There's also a ton of YouTube videos if you're so inclined. Now, on my milling machine, when I want to hold a part down, the most common method is to use a vise. And there's a special machinist vise which holds your part solidly to the table. They're usually bolted right to the milling table on the machine. You can also use a vise on a CNC router, provided you have some way of mounting it to the bed of your machine. Now, machinist vices are kind of expensive. the least expensive machinist vise I've ever owned was about $150, and that was from Shars.com. But they are typically a $500 or $600 item when you get up into the larger sizes. They're very solid, very strong method of holding things, but they have their limitations. For instance, the jaws have a fixed width that they can open and that will limit the size material that you can hold in place. Now, one cool part about a machinist vise is you can take the jaws of the vise off and move them to the outside edges of the vise and probably triple the size of the workpiece that you can hold. And, that is a valid method for holding, large sheet parts that you're going to profile parts out of. So, that is one way of doing it. If I were looking for a machinist vise right now and I wanted to save some bucks, I would probably check out a local Craigslist or, go online to eBay and see what they had. You're probably not going to want to ship a machinist vise because they're heavy and they cost a lot to ship. But if you can find one locally, you're probably ahead of the game. For those times when the machinist vise won't hold a piece, and I ran into this just last week when I was making some fixture plates. I tried a method that several people have been talking about for a while, but I had not tried, and that is to use painter's tape and CA glue. And CA is cyanoacrylate, which is basically super glue is probably the most common name for that style of glue, but it doesn't have to be super glue brand. It can be any of the instant glues. Essentially what you do is you place down a layer of painter's tape on the bed of your machine and burnish it down with a round object or whatever to make sure you get all the air bubbles out. And then you do the same thing to the back of your workpiece that you're about to cut. Now there are a few steps to make your odds of success better. For instance, if you're about to machine aluminum, you can clean the surface with acetone or denatured alcohol to give a good bond, and then take a Scotch-Brite and just lightly scuff the surface before you put the tape on and burnish it down, and that should give you more than enough adhesion to hold. You're wondering, well, blue painter's tape hardly holds, comes off the wall easily or whatever, but in this instance, it works really well, and it has something to do with the surface area and other scientific stuff I'm really not up on. But when you spread a layer of the super glue onto the tape, and then you place your material in it, it forms a glue tape sandwich there, and you put some pressure on the part to clamp it in place and let it set for 15-20 minutes. When you come back, you are able to machine that piece just like in any other fixture that you had. I've tried it with deep roughing cuts. I've tried it with face cuts. I've tried it with profile cuts, all sorts of things with no problem. And I've even used it with flood coolant and not had a problem. Now, you should definitely do your own tests on your setup and, be aware of the possibility that it may not hold. But I've not had any problems whatsoever. In fact, it holds better than most things. But it allowed me to make 14-inch by 8-inch plates, which I had not previously had any other way of holding in my machine to do. And this allowed me to do that in one clean facing operation and have one big smooth surface on the top of it. It was really, really eye-opening. And then I, began trying it with other types of cuts. Everything went great. So, there's a ton of videos on YouTube which talk about this method. There's a really good one by John Saunders of NYC CNC that talks about it, and I'll throw a link into the show notes for that video as well, that show this technique in use. There's also a really good video by a guitar maker who used this method to hold down fretboards on his CNC router. So, definitely a way to check it out. Now, the whole reason I was making those large fixture plates was because of another method of work holding, which is a pallet system. Now, this pallet system that I'm talking about could be used with either a router table or a mill, but it's actually designed for a mill, and it's a little on the expensive side. In fact, for most people, it would cost about the same as, let's say, an X-Carve. Okay, they're kind of expensive, about $1,000 all up. But the point of the pallet system is that you could load up a bunch of parts on them, place it on the machine, press go and have the machine do its cutting while you have another identical pallet or a different set of parts either being loaded up on another pallet. And when the machining is done, you release the lock on the pallet, lift off the one that you just machined, and replace it with the set of parts that you just loaded up, and hit cycle start, and off you go again. This allows you to do, production work or, even projects with multiple parts on one pallet, one fixture plate. And, it's a really cool system, and it's I'm really happy with the setup that I just got from Pearson Work Holding. And I'll put a link, again, in the show notes to Pearson Work Holding. I got their mini pallet system. Pearson also offers vacuum pallet systems and a larger professional pallet system. But the one that fit my needs was the smaller one. And I got to tell you, it's probably one of the better purchases that I've made in the last few years. It allowed me to go from making parts one at a time to making them 6 at a time or 8 at a time, or however many I can fit onto that pallet. And I think it was a pretty cool method to use. All right, and yet another work holding method to use is double-sided tape, or carpet tape in some cases it's known as, although most times carpet tape is thinner than double-sided tape that has a foam liner in between. I've used both. I use carpet tape when I'm doing acrylic work, and I've used double-sided tape on pretty much everything else. In most cases, they hold very well, although some woods that are particularly oily don't take very well to it. But you apply a layer of the tape, you remove the protective backing, and you push it down onto your spoil board of your machine, and go ahead and machine your part. The good part about the double-sided tape is that it allows you to mill the complete profile of a part without worrying about the part coming loose from the spoil board. And that can be very handy when you want a nice clean edge on something, without using tabs to hold your piece down. While I'm thinking about it, one of the methods of work holding that I started to use quite a bit now in both my router and the mill is in conjunction with the vise. I use soft jaws. Soft jaws are aluminum or brass jaws that replace the steel jaws on your vise. And what's cool about them is you can take the outline of your part and lay it out in CAD and then machine it into the top surface of these jaws, so that it's going to be an exact fit to the part that you're making. And so when you've removed the material for your part, it forms a really nice pocket. And so you place the rough part in there, and you tighten it, and you tighten the vise down, and it clamps it around the edges very securely. And that allows you to, machine your part. And I used that method in one portion of the triple edge finder when I'm making those. It's a very good way to avoid having to spend a lot of time finding your work offsets and your Z0 position, because you just pop one in, pop one out of this soft jaws, and everything should be ready to go between cycles. So that's a pretty cool method that you can use to hold your part. Yet another work holding method is fixture plates. There are several out there that are a series of pre-drilled and reamed holes milled into either aluminum or steel, depending on which kind you buy, and they fit to the bed of your router table. And you can then use clamps or dowel pins or what have you to arrange multiple parts on the table or a single part on the table and hold it in place. The fixture plate is probably one of the coolest things that I've seen, and I hope to have one for my router table very soon. We used fixture plates at Morrisville College, where I am an adjunct instructor and teach a course there. And we used that when we made the side panels for our CNC router table there. We had, in this case, a fixture plate that was made out of UHMW plastic, and that's ultra-high molecular weight plastic. And we had drilled and tapped holes all over the surface of that, so we were able to take a piece of bar stock or plate stock and mount it on the table, and then go ahead and machine it and machine all the way down around to it. Now, the good part about having that style fixture plate is after you get one or two holes drilled into it, if you plan properly, you can use the holes that are in the fixture plate to secure the workpiece, and then continue machining around the edge or profile or whatever you have to do to it. So, you can have the clamping situation just keeps getting better as you work further and further into the part. The nice part about having a fixture plate that was made out of plastic was that if we accidentally cut into the surface or intentionally cut into the surface, we could just go and fly cut the top again and restore it to a good level, clean surface. And if we had to retap a hole, so be it. If not, no problem. But having a fixture plate can be a real time saver, particularly if you do a lot of different parts. Folks, the reality is there are probably as many ways of work holding as there are work that needs to be held. And it is just one of those things. There are a ton of solutions that are out there. You've got companies that are entirely devoted to producing different methods of work holding. Like, for instance, Mighty Bite. They're a company that makes all sorts of accessories for professional machining that holds fixtures down. They can be quite expensive as well, but they do a great job of holding parts down. It really depends on how ingenious you are, how much you think about it beforehand. Often your first reaction is to just use some clamps and hold your part down, and then you get into the process of machining it and realize that while it was great to start, you can't finish the operation in the setup you had, and then you have to come up with a way to move forward without losing the reference to where you currently are, but yet still holding your part in place. And so there's a lot of thought that needs to go into your work holding process before you get started. And this is an area that causes beginners and even experienced CNC users a lot of grief. So, I just thought I would briefly go over some of the major ways that people hold their parts down. And I hope this was helpful to you. Again, links to most of these types of work holding will be included in the show notes. You can see them by going to CNCRouterTips.com/58, the number 5 and the number 8. So that's CNCRouterTips.com/58. I really encourage you to go and check out the show notes for this episode, because I'm going to include, along with the show notes, some pictures of the process that I went through holding down some parts using the painter's tape and super glue method. Also, some of the pallet pictures from, using a pallet system and vise and many other things. So you'll get an idea, just looking at at these examples of how this stuff works and, what kinds of things it could be used for. And I think that might be helpful to some of you who are just getting started. So once again, that's CNCRouterTips.com/58. We'll be right back after a word from our sponsor.
Today's episode is sponsored
Some of
by
you may wonder,
The Maker's Guide.
Okay, how do you wire up
the triple
a
edge
limit
finder.
switch or a home switch?
Get the edge you need. Save time and frustration on your CNC project and make setup a snap. Save time and material. Set up your workpiece on your CNC router table faster than ever. Accurately set your Z-axis height first time, every time. Automatically locate the corner or edge of a workpiece. Reset your starting point in the middle of a program. Quality crafted right here in the USA on US-made CNC machines. Get the edge you need today. Go to www.themakersguide.com/edge. The Maker's Guide. Useful tools for makers.
All right, we're back, and I got to say that April was one of the busiest months that I've had in a while. There was a lot going on in both my personal life and my business life. My daughter and her husband moved back from the New York City area. That was a really welcome treat. She's starting new jobs here in central New York. And my wife's family came to visit for a week, which was really great. I happened to have the greatest mother-in-law in the world. So, all you guys just feel envious. But she came up to visit us, and I had a blast getting to spend some time with her and my wife's brother and sister and my brother-in-law's wife. All were here. It was a great time. So, from a business standpoint, I had made the decision that April was going to be the time when I switched over my production method for making triple edge finders. And so I, went out into the shop and I made up a big batch of triple edge finders so that I would have inventory while I made the transition. And I blew it. Yep. I underestimated how many I would need, and I ran out about 2 to 3 weeks before I was done. So, thinking that the supply I had was going to be adequate was a big mistake. Should have made more. Well, now I can. But it was quite an adventure because I'm combining several different methods to make these new parts. Before I had a a fixture that held one part at a time while I did the operations on the top, and the bottom operations were done in a vise. And so for each part, you had to take out the raw part, or take out the finished part, put in a raw part, get it lined up and tighten down, and then go ahead and mill it. And so there were several secondary operations that you had to do that had required different fixtures and things like that. And I wanted to be able to make more than one at a time. And so, I did some research, and I figured out that Pearson mini pallet system was going to be the way to go. It would allow me to make somewhere between 6 and 8 parts, depending on how I laid it out at a time. So I broke out my CAD software and went about designing the part, got it all designed, and then ordered the raw material to make the fixtures. And when I received the material, I realized that I had no way of holding it to the machine. That's why I got to thinking about doing this episode about work holding. And so I came up with one method where I moved the jaws of the vise out onto the edges of the part, and I could hold the piece in place, but that left parts hanging over the edges of the vise that needed to be supported. And so I kludged together something, and I got to thinking, this is okay, but if I need to do another one, it's going to be a real pain. How should I do this? And I had kept hearing about this painter's tape and super glue method for doing things. And all I really wanted to do was give this big plate of aluminum a nice face cut. Just run the fly cutter over the top, and then begin machining my part so that the part looked nice when it was done. And so I got to thinking, well, I wonder if it will hold up for this. And I got to looking around, and I did some research, and I decided to take a risk, and to try that method. And believe me, I was skeptical that it would hold, particularly with flood coolant. But I decided to give it a shot. And I used the method that I described earlier in this episode to hold it down. Put the painter's tape down, burnish the ends, put the super glue on, and mount the part. And then, I did the fly cutting, and it just went perfectly. And after the fly cutting was done, I said, I wonder if I could drill the holes. So I drilled the holes. I said, wonder if it'll hold up to me machining the counterbores. I need flood coolant for counterbores. Let's take a risk. Counterbores, no problem. Wonder if I can profile in this. And the profiling went great. So all of the operations that I needed to do were I was able to do to that fixture plate with the painter's tape and the super glue. And I made 2 or 3 plates that way, one for the top operation, one for the bottom operation. Got it all together, mounted to the pallet plates, and everything was fine. And then I had to go about dialing in the CAM software to make it sure that all the parts came out nice. And I went through a few pieces before I got it exactly the way I liked it. But man, what a time saver! The combination of this pallet system, doing multiple parts with the tools, etc., it just really freed up the amount of time it takes me to make these, and I think the quality is better than it was before. So I'm very happy that I made the decision to go forward and try and tweak or improve the way that I was making these parts to allow me to make more of them. So it was overall a great learning experience, and a great mind shift, to how to do things. So anyway, that's the story of my little adventure into work holding, and why this was on the top of my list of things that I felt like talking about today. So I hope that you learned something from this episode and that you'll find it useful. If you'd like to get to leave a comment about this episode, I would really appreciate it if you would do that, particularly if you leave it as a comment in iTunes. You could leave a rating and review for the show in iTunes, and that would be just fantastic. If you've got an iPhone, you can do it from right inside the iPhone. Just at the end of the episode, scroll down, and there's a place where you can do a rating and review. It really helps to grow the awareness of the show, and so I would appreciate that. You can also check out our Facebook group. Our private Facebook group is #CNC Router Tips. And you can find that at facebook.com/group/CNC Router Tips. And, join that group. It's a rapidly growing community of CNC enthusiasts. We've got over 12,200 members as this point. And we'd love to hear from you. I often mention many different types of software during the episodes, and hardware and cutters, and it can get a little confusing. So what I did was I put together a page on my website, cncroutertips.com/resources. And on that page, I list all sorts of resources there, from books to tools to software, all the things that I use that make my CNC experience better and easier. And I hope you'll check it out. So again, it's cncroutertips.com/resources. Now, if you'd like to have your question featured on the air, here's how. Need help? Ask me about your CNC router question on my podcast, the CNC Router Tips Podcast. I'll be glad to help or try and get you the help you need. I want this podcast to be a fun and personal experience for everyone, and helpful. So let's keep it real and ask sensible questions. Please use common sense and show courtesy to everyone. That way everybody wins. Here are some guidelines to ensure that your question is qualified to be featured on the show. Please keep your questions under 1 minute in length. If it goes a little over that, that's fine, but don't ramble. If you have a website and URL, you're allowed to share it, but only once during the recording. Spammy or disrespectful or deeply private questions will not be considered for the podcast. If you need to ask more than one question, just make each question a separate voicemail. That's it for this episode, and thank you, folks, for taking the time to listen in. I'm Bill Griggs. Have a great day.